Hey guys, we're gonna do Wednesday. I have started to highlight some key things. I was trying to work out number one before I came on here. So it says Joe has a bag of 24 marbles. So I'm going to draw 24 marbles. So what I did is I made 3 rows of 8 because 3 times 8 is 24. So those are the marbles that Joe has, and he's going to give a 4th to Sue and an 8th to Pete. We're going to do this with a picture so that we can figure out how many marbles Joe now has remaining. So if I divide the picture into 4ths, because Sue's going to take a 4th, I'm going to make a couple groups. Here they are. Here are my 4 groups. 1, 2, 3, 4 groups. And Sue takes one of those 4 groups. So Sue right now got 6 marbles. Does everyone see that? Okay, now Pete. It says Pete took an 1/8 of the bag. So that means that we need to group the marbles into 8 groups. So all I'm going to do is I'm just going to make another section in the set to group them into 8 groups. So let me show you what I mean by that. So now I have 8 groups. Let me show you where they are. This is group number 1, 2, 3, 4, 5, 6, 7, and then group 8. See how I went from 4 groups to 8 groups? And I still kept Sue there. And then it says Pete takes one of those 8 groups. So I'm going to take this one group right here. And that lets me know that Pete took 3 marbles. So the picture now shows us in white, the white marbles that don't have X's on them are what Joe has remaining. And so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this shows us that he has 15 marbles that were left over for him. Awesome. It's a great way to do math with pictures. I always told you guys, if you can do it with a picture, do it with a picture. No one is holding you back. I think conceptually understanding something is really important when we're doing math and we move into an algorithm. All right, let's look at number 2. I was a little confused on number 2, but I think we're going to be able to tackle this together. So it says which numbers below round to 238 if we round the 10ths position. So that means we need to go through and round every single one to the 10th position. And if we end up with the whole number of 238, awesome. If we end up with a number bigger or smaller than that, it won't fit what we're looking for. So let me give you an example. So 238 and 96 thousandths. So we're rounding to the 10th place. If I look next door, that means the 9 is going to bump the 0 up to a 1. So this one turns into 238 and 1/10. But it doesn't give me the whole number 238 without any extras. Okay, remember we're just looking for 238, not 238.1, not 238.5, just 238. So to me, that one won't fit it. Hopefully I'm understanding this problem the same way that you are. So I want you to try the next one. We're going to round that to the 10th place. So if I look next door, the 8 is going to bump the 9 up to a 10. But really what happens is if this is a 10, this becomes a 0 and the +1 comes up here. So this number actually turns into 238. And no, nothing in the change section or the tens, hundreds, thousands. So to me, this one rounds up to 238 as a whole number because we can write 238.0 as 238. Okay. That is really tricky right here, so I want you to pay attention. Like you can't have 2 digits in one place value section. So your 0 from your 10 will go here, and then you'll carry over the whole. Okay, let's do this one. Again, rounding to the tenths place, I look next door. It's 4 or less, so it's going to let the 9 rest, and I'm going to get 238.9. Again, doesn't fit the whole number of 238. All right, let me do this bottom one here. So 238, rounding to the tenths place. When I look next door, it's a 2. So if there's a 2 there, that means the 0 is going to stay the same. We're not going to round it up to the next digit. And that leaves us again with 238 and no tenths, or so we can just write it as 238 as a whole. And for me, that would fit. What did you say? Yeah? Okay. 2 more. 237 and 938 thousandths. We're rounding this tenths place. When I round, the 3 is 4 or less. We're going to let the 9 rest, meaning it's going to stay the same. And that doesn't meet our goal number of 238. So that one doesn't fit. And the last one, 237, 961. Okay, we're rounding to the tenths place. So I'm going to look next door. 5 or more, we raise the score. So remember up here what happens when you want to change the 9 to a 10. So really this becomes a 0 and your plus 1 goes up here. So it becomes 238. And that fits the rule. So I hope you were able to follow the rounding there, okay? All right, let's look at number 3 on, hey kitty, on the fraction models. It says, which fraction model below is equivalent to 75 hundredths? I'm going to write down right now that 75 cents is equal to 3/4. And you should know that as one of the first fractions that we learned their decimal equivalents to, because it was really easy for us to relate it to money. If we have 4 quarters and you have 3 in your pocket, then you have 75 cents. So moving forward, we're going to look for fraction models that have 3/4 shaded. Okay, so I'm going to show you how we can do this with just the pen. I cut my circle into fourths. I see that 1, 2, 3 of the 4 sections are shaded. So guess what? This one's equal to 3/4. This is cut into 1, 2, 3, 4, 5 sections. And I know it's hard to see on the camera, but 4 of the 5 are shaded. And I know that 4/5 is equal to 8/10. It's not equal to 75 cents. So this one is not correct. Okay, same sort of deal here. Circle cut into 4 parts. 3 of them are shaded. Out of the 4, that means 3/4 is matching 75 cents. So that one also works. Oh, I'm loving this. I miss having you guys in my class. Okay, let's work on this bottom one. Again, this one's kind of hard to see, but it has 3 columns. 1, 2, 3. And it has 2 of the 3 sections shaded. My cat's trying to get in the video and make a premiere. So 2/3, what do you guys think? Are you not sure? I'm going to draw the picture out so that you can see it, and then I want to play with this with you. Okay, so this is what it looks like. So when I first looked at it, I saw, let me do this. I saw this. And I saw 1, 2, 3 columns, 2 of the 3 shaded. Now, I'm going to do some manipulating around before I count this fraction not equal to 75 cents. And this is what I mean by that. I'm going to take this out. It's going to go bye-bye. And I'm going to move it up here. Okay, and then I'm going to move this out. I'm going to move it up here. And then I'm going to reassess at what I have, okay? And the reason why I did that is because I actually saw 4 sections over here, and I just wanted to make sure that I didn't have 3/4, okay? So, nope, 2/3 is equal to 0.66 repeating, so that one doesn't fit. Okay, I'm going to move a piece over in this next square just to make something visual for you, okay? So I'm going to take this triangle down here and I'm going to put it over here. And the reason why I did that is because then I can see nicely that that fraction model has half of the square shaded. And I know that half is equal to 50 cents, not 75, which is our goal. So I'm not going to choose that. Okay. And then let's see here. I don't know if you can see this, but 4 are shaded here, 3 are shaded here, and 1's shaded here. So I actually see 4 sections. You see that? I see 4 columns. Columns go up and down. So if I take this block right here and move it right here, then I actually have 3 out of the 4 columns going up and down, okay? I actually have 3 out of the 4 columns shaded. So that matches the 75 cents. That was a really tough one. I hope you guys were able to hang in there with me. Okay, let's look at number 4. It's our word problem. Hopefully we can use a calculator, but you know how that goes. All right, number 4. Number 4 says, I have 18 children in my family, and I have to give each of them a present at Christmas. I went to the mall and purchased 563 gifts. My goodness. How many presents can I give each of them? So I'm going to say 18 children. Each of them gets 1 present, or each one of them gets presents, and we don't know if they're going to get 1 yet. And I went to the mall and purchased 563. How many presents can I give away? So she's giving away presents. She's dividing out her 563 presents among her 18 children. So let's just do this some traditional way. Can 18 go into 5? No. Can 18 go into 56? Yes, we need to figure out how many times. So 18 times 2 is 36. So we're going to try to get a little bit closer. 18 times 3 is 54. And I'm going to stop right there because I know if I do 18 times 4, I'm going to go too far. So 18 times 3 is 54. 56 minus 54 is 2. I'm going to bring down the 3. Can 18 go into 23? Yes, 1 time. I'm not going to regroup here. I want you to count up from 18 until you reach 23. So I'm starting 18, 19, 20, 21, 22, 23. You should have gotten 5. So it looks like there are 5 presents left over. But it looks like when she shared her gifts to the 18 children, each child got 31 gifts. Wow. She must be really rich to get 31 gifts to all of those people. That's a lot. Okay. Let's move on. This one I'm going to do is going to be the last one for Wednesday. I'm actually going to make a separate video for Thursday. And I'm going to do this with just a picture. Sue has 12 new hair bows. Okay, they have already drawn the 12 bows for you. She plans to give a third of them away to her friends. And I want to know how many hair bows will she be giving away. If I say, I'm going to give a third away, what amount does that actually equal to? Okay, so I've got 12 hair bows here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm giving away a third. The denominator is very crucial in your thinking. The denominator tells you how many groups you're going to make. So my denominator is 3. I'm going to make 3 groups. So I'm going to draw a line. Here's group number 1. Do you see it? Okay, I'm going to draw another line. Group number 2 and group number 3. And she's going to give away one of the groups. How many bows is that? If you said 4, then you are correct. And you didn't even have to do the multiplication. But you could do 12, 1/3 of 12 is 4. Because 12 divided by 3 is 4. I like the picture. Awesome job. I'll be back for Thursday, okay?